what we are talking here is that again possibly you can write deduce an expression for fringe width in Young's double slit experiment. Okay, a bit of background, those who have not really done enough work on this. I had explained what is superposition, okay, and then also I had explained what is coherent sources and incoherent sources. So just for those who possibly are not on the same page, again let me repeat that the two sources are said to be coherent when both of them they actually have the same phase difference or a constant phase difference and are moving with the same frequency as well as the velocity. Both the sources are of the same frequency, moving with the same velocity and with the same with a constant phase difference. Okay, clear ho gaya? This is called coherent sources. For a Young's double slit experiment, we need to have two coherent sources. Okay, now how do we really achieve those two coherent sources, and what is the purpose of these two coherent sources? Is to actually achieve my interference patterns, and interference patterns में क्या क्या मिलेगा हमको? Constructive interference as well as destructive interference. All right, so let us just discuss how do we really generate two coherent sources. So it is a what Young has done, took a cardboard, okay, something like that, and there was a hole in this cardboard like this, and then there is a bulb here, we can call it a source. For example, suppose you keep a bulb like this, it's a source. So from here what you will have? You will have the wavefront like this. Okay, so I will call it the source S, and again let me just there are two holes, something like that, and then there is this again the same another cardboard like this. Okay, so this is a cardboard, and then we made two holes. So these two holes means what? These two holes, it simply means that the light will actually travel through these two holes. Okay, and then we have got a screen somewhere here like this, and the center point of the screen is this point. Okay, so I'll call this O. Now obviously let me put a point here P, and this is source 1 as well as this is source 2. From source 1 there is a wave that is going and meeting at P. Also from source 2 there is a wave which is going and meeting at point P. Now when two waves are hitting at same point P, we need to see which kind of pattern or what kind of pattern we are achieving, whether it is destructive or constructive. Okay, is it clear? Now let's take two things. One, from S1 if we put a horizontal line, and also if we put a horizontal line from S2, let this distance be known as, let us say this point is known as A and B, and AB distance, let me demarcate it as D. Okay, and then this would be D by 2, obviously it will be half, and also this will be D by 2. Is it clearly understood? All these assumptions. Let me say from the center point, the distance of P where the fringe is made is X. Okay. Now, this distance, let us take it as capital D. It is the distance between the second cardboard which is having two sources S1 and S2 and the जो भी आपका कर्टन है या पर्दा है, ये स्क्रीन कह लो आप, जो भी कहो आप उसको, ठीक है, स्क्रीन. Let me write down. Now we want position of bright and dark fringe. What is the purpose? Position of bright and dark fringe in Young's double slit experiment. In Young's, ये जो हमने बनाया है diagram, this belongs to Young's double slit experiment. All right, so this is how. Let us go and do some mathematical investigation. Now let me just if you see S2P minus S1P, okay, yes, सबसे पहले हम जान लेते हैं what is path difference. Basically there are two paths, one is S2P and other one is S1P. So S2P minus S1P, let me call it as simply P, which is the path difference. Okay, so if I say S2P square minus S1P square, then I can definitely write it as S2B square plus PB square, and then minus S1A square plus PA square. Can you connect it with this? Tell me. S2P square, S2B square, that is this. What can I draw? S2B is this line, okay, and then PB is this line, PB is this line. So S2P निकालना हो तो मुझे क्या करना होगा? इसका स्क्वायर एंड इसका स्क्वायर करना होगा, नहीं करना होगा, राइट? So S2B square plus PB square would give me S2P square. So it is correctly written now, simply Pythagorean है. Similarly minus S1P square would be S1A square plus PA square. Okay. Now let's write down this thing, distance. S2B would be capital D square plus PB को हम क्या लिख सकते हैं? S2B would be D square plus PB को हम लिख सकते हैं जी x plus d by 2. Can you check on your end? Can we write it like that? Minus d square plus x minus d upon 2 का होल स्क्वायर, ऐसा लिख सकते हैं. एंड इसको भी हम ऐसे लिख सकते हैं. So let's try to further open it up. So I will get again d square plus x square plus d square upon 4 plus 2xd upon 2. So 2 से 2 कट जाएगा तो simply xd plus d square plus x square plus d square upon 4 minus xd. But here it was, since negative sign was there, so I will put it as negative. Also this will be put as negative, okay, and this will also be put as negative, and this will become positive. So we can cut this d square, cancel, x square also cancel, and d square also cancel. So what we really got is 2xd, 2xd. But this can be written as S2p plus S1p into S2p minus S1p. ओके, ठीक है. And S2p minus S1p is nothing but the path difference p, and so my path difference S2p minus S1p will be 2xd upon S2p plus S1p. ओके, बहुत ध्यान से देखें हम तो S2p would be approximation कर देंगे S1p के साथ, and finally this can be approximated with d. Okay, reason is very simple, because these angles are pretty small, therefore they can be approximated with capital D. So what we can write here, our path difference is 2x small d upon capital D, and here I can write it as a simply path difference p. Okay, this is my path difference p. Okay, this is my path difference p. It's very important discussion. ये एग्जाम में जरूर आता है, एवरी ईयर आता है, डिपेंडिंग ऑन विच पेपर यू गेट. So this is the condition for my path difference. Now if path difference has to be multiple of lambda for position of fringe. For constructive interference क्या करेंगे? That's my condition 1. For constructive interference, if you remember my discussion that I have taught you, P has to be n lambda, and n belongs to Z, right? So I can write 2xd upon capital D as n lambda, and x would n can be what? N can be 0, 1, 2, 3 and so on. I can remove this in that case if I am mentioning this. Okay. So if I say, what do I get? The position of various bright fringes would be based on this. The position of various bright fringes वुड बी, पहला कब बनेगा, व्हेन n इज इक्वल टू 0, राइट. सो कहां बनेगा, लेट मी राइट, करस्पॉन्डिंग x विल बी x नॉट, x नॉट वुड बी 0. तो कहां बनेगा, सेंटर पे ही बनेगा बिल्कुल, राइट. तो आप देखो पहला फ्रिंज हमारा कहां बनेगा, वापस जाते हैं अपने इस पे. सबसे पहला फ्रिंज आपका यहीं पे बनेगा. ए ब्राइट, आई विल ड्रॉ समथिंग लाइक दिस, एंड यहाँ पे इसको मैं आगे लेके जाऊं तो यहाँ पे एक ये ब्राइट स्पॉट बनेगा लाइट का, समथिंग लाइक दिस. इट विल कंटिन्यू टू गो लाइक दिस. सो सेंटर पे यू विल हैव ए ब्राइट पॉइंट, a lot of light would be there. That would be my, when x is equal to x naught would be 0. So central bright fringe कहेंगे इसको, क्या कहेंगे इसको, central bright fringe. ये आपको बहुत कुछ याद रखना है while you solve the problems. It's very important. For n is equal to 1 क्या मिलेगा हमको, let us see. n is equal to 1, I will get x1, and what will be x1? x1 will be d lambda upon small d. So that is my first bright fringe. First bright fringe. First bright fringe. And n is equal to, इसी तरह से हम 2 पे रखेंगे तो मेरा सेकंड ब्राइट फ्रिंज मिलेगा मुझे 2d lambda by d. Yes. So I'll call it as second bright fringe. तो मुझे nth bright fringe चाहिए तो मुझे क्या करना होगा, I will have to write like this. For n is equal to n, I will get xn माने nth. So it will be n d lambda by n d lambda by d. यहाँ पे देखो थोड़ा मिस्टेक हुआ, इसको ठीक करो. स्मॉल d होएगा यहाँ पे एंड यहाँ भी स्मॉल d होएगा. So xn will be this. Is this clearly understood? Any one of you who do not understand this conversation? Kshitija, Prakhar, is there any problem with you to not switch on your video? What is the point?
I just rejoined.
Network issue हो रहा था इसलिए.
Okay.
Same. I've had a power cut thrice in the last 10 minutes or so.
Okay. But please, once it is not there, make it automatically. So we know now xn. Let us talk about dark fringes. Dark fringes would occur when we have destructive interference. Okay. So we will talk about dark fringes. Condition for dark fringes. Let me say that my condition for P was x lambda. So basically it should be मेरे पास क्या होना चाहिए, x d by d condition. This has to be basically equal to 2n minus 1 into lambda by 2. Odd multiples of lambda by 2 पे हमें क्या मिलेगा, डार्क फ्रिंज और डिस्ट्रक्टिव इंटरफेरेंस. जब दो वेव्स लैम्डा बाई 2, 3 लैम्डा बाई 2, 5 लैम्डा बाई 2 एंड सो ऑन इन पे मिलेंगे तो वहां पे क्या होगा, कंप्लीटली डार्क होगा. व्हाई? बिकॉज दे आर इन ऑपोजिट फेस. समझ रहे हो? ऑपोजिट फेस पे इंटेंसिटी क्या थी, 0. अंडर रूट i1 माइनस अंडर रूट i2 होल स्क्वायर एंड i1 इज इक्वल टू i2 इन दिस केस. दोनों सेम ही सोर्स से ड्रॉ कर रहे हैं तो i1 अंडर रूट i1 माइनस अंडर रूट i2 वुड बिकम 0. देयरफॉर वी विल गेट अ डार्क पॉइंट. सो कहीं हमें बिल्कुल ब्राइट पॉइंट मिल रहा है जब मैक्सिमा होगा मेरा इंटेंसिटी, और कहीं कहीं हमें क्या मिल रहा है, बिल्कुल डार्क पॉइंट मिल रहा है. सो डार्क पॉइंट आर द पॉइंट्स ऑफ डिस्ट्रक्टिव इंटरफेरेंस एज एन आउटकम, and bright points or bright fringes are the outcome when the path difference of the two waves is multiples of lambda. Okay, lambda, 2 lambda, 3 lambda, and so on. So these are our outcomes. So if we see these outcomes, similarly dark fringes के लिए हम क्या करें, n is equal to 0 पे हम क्या कर देते हैं, x dash 0, वहां पे x लिया तो यहाँ पे x dash ले लेते हैं. All right. So what shall we get? In fact 0 पे तो हमें already bright fringe मिला था ना. So n has to be 1 at least. So n has to be 1. So x dash 1 मिलेगा हमको. सेंटर पे तो हमें कुछ ऑलरेडी ब्राइट फ्रिंज मिल चुका है. सो यहाँ पे क्या मिलेगा, इट विल बी सिंपली x1 विल बी, अब यहां से x निकाल लीजिए, x विल बी लैम्डा, वी विल राइट कैपिटल D लैम्डा बाय स्मॉल d, ओके, एंड 1/2 बिकॉज लैम्डा बाय 2 है, सो 2d, that would be my thing outcome. So n is equal to 2 पे क्या मिलेगा, x2 dash, and I will get in the way 3 upon 2 d lambda by d. N is equal to 3, x3 dash would be 5 upon 2 capital D lambda by small d. All right, and similarly what will be my x dash n, x dash n would be 2n minus 1 capital D lambda upon 2 small d. Okay, so I'm sure you must have understood this. Now width of the fringe will be what? What is the fringe width? Width of a bright fringe. चलो अपन bright fringe की निकाल लेते हैं width. Bright fringe, if you notice my width would be xn minus 1. दो consecutive जो points हैं bright points, उनके बीच की जो width होगी, it would be the width of the bright fringe width. Yes or no? Tell me. Let's put these points. It will be n capital D lambda by small d minus, n की जगह अब n minus 1 लिख दो, capital D lambda by small d. So क्या हो जाएगा, d lambda by small d. This will be your fringe width. And so width of a bright fringe is separation between two consecutive dark fringe. Okay, so what would you write? देखो आप ध्यान से देखोगे तो इट विल बी लाइक दैट. यस, ए इस टाइप से होता है, ये ऐसे. यस, सो दिस इज योर डार्क, दिस इज ऑल्सो योर डार्क, एंड इन बिटवीन यू हैव दिस ब्राइट. यस, बिकॉज लाइट यहाँ पे है, समझ रहे हो. तो हमें क्या मिला, हमें मिला जो bright width of a bright fringe is separation between two consecutive dark fringe. This is nothing but separation between two consecutive dark fringe. Okay, and So if you see, इसको थोड़ा सा यहाँ इसके साथ नहीं यूज करते, so that you should not get any kind of confusion. इसको हम कह देते हैं आपको, this will be known as beta, width of a bright fringe. Okay, तो width of a bright fringe is what is the definition of a width of a bright fringe? Beta, it is the separation, it is the separation between two successive successive bright or dark fringes. This is called fringe width. Okay, but if you want to know what is the fringe width, इसको जनरलाइज ही कर देते हैं, so that you don't really get into any kind of confusion. Simply we define it as a fringe width. Fringe width. So what is a fringe width? It is the separation between two successive bright or dark fringes. Two successive bright or dark fringes. Simple. Make it simple. Okay. So here I get my beta. Also, if I have to get width of a suppose I want to get separation between two consecutive dark fringes, so width of a bright fringe is nothing but xn minus xn dash. It can also be described as separation between two consecutive bright fringes. And this is same way we can know x dash n minus x dash n minus 1, which would be what? 2n minus 1 capital D lambda upon 2d minus we will write twice n minus 1 minus 1, okay, and then capital D lambda by 2d small d equal to d lambda by small d. Okay, so either way fringe width remains same. Did you get it? Either bright or a dark fringe width exactly same, no change. ठीक है जी. Here one thing that is to be noted is that beta is independent of n, independent of n, the order of the fringe, the order of the fringe. Are you clear about this? Therefore all fringe are equal width. In the case of light, lambda is extremely small, so capital D should be much larger than small d. Okay, is this clear or not? And if you want to know what is your lambda, so lambda can be known as beta times small d upon capital D. Clear? So this is what we have discussed today. Let me take couple of illustrations to support this discussion. All right. Okay. Let me write a question for you. In Young's double slit experiment, using light of wavelength 400 nanometer, using light of wavelength 400 nanometer, interference fringes of width x are obtained. The wavelength of light is increased to 600 nanometer, and the separation between the slit is halved, and the separation between the slit is halved. Halved means आधा कर दिया. If one wants the observed fringe width, if one wants the observed fringe width, on the screen to be the same in the two cases, on the screen to be the same in the two cases, in the two cases, find the ratio of the distance between the screen of the distance between the screen and the plane of the interfering sources in the two arrangements. So tell me, anyone of you can think about it? So there are two cases. In the first case, what will be the fringe width? X would be d1 lambda 1 upon d. D remains the okay in that case. And in the second case क्या बोला उन्होंने? In the case 2, x does not change, but d1 becomes d2, lambda becomes lambda 2, and d has become, small d has become half as per the question, halved लिखा है. So if we equate the two, we would get d1 lambda 1 upon small d is d2 lambda 2, or rather twice upon d. Okay, so what is it that we got? We getting d1 upon d2 will be twice lambda 2 upon lambda 1. So d1 upon d2 would be twice, lambda 2 is what, 600 nano, and upon lambda 1 is 400 nano. So what will I get? It will be 3 upon 1. So the ratio of d1 is to d2 would be 3:1. So you should do similar problems at home. Is this clearly understood or not yet? Tell me. Let us do one more problem to support Young's slit experiment. In a Young's experiment, the width of the fringe or fringes obtained with the light of wavelength with the light of wavelength 6000 angstrom is 2.0 millimeter. Okay, calculate the fringe width. Calculate the fringe width. Calculate the fringe width if the entire apparatus is immersed. If the entire apparatus is immersed in a liquid of refractive index 1.33. बताओ विधि क्या करें इसमें विधि. What is my input in this case?
I'm not sure what to do.
So I would suggest, जैसा कि मैंने आज कराया है, ये घर पे बैठ के इसके न्यूमेरिकल्स करो, बिकॉज आई एम टेलिंग यू 5 मार्कर आ सकता है, 3 मार्कर में डेरिवेशन एंड 2 मार्कर में इसमें न्यूमेरिकल्स आ सकते हैं. सो देयर इज क्वाइट स्ट्रॉन्ग गुड चांसेस. ऑल्सो देयर कैन बी ए केस स्टडी बेस्ड ऑन द कॉन्सेप्ट अंडरस्टैंडिंग. ओके, सो हमको क्या दिया है? रिफ्रैक्टिव इंडेक्स ऑफ ए लिक्विड म्यू, यहाँ पे लिखो रिफ्रैक्टिव इंडेक्स ऑफ ए लिक्विड. क्या होता है म्यू? म्यू होता है लैम्डा इन वैक्यूम और एयर, राइट, अपॉन लैम्डा इन मीडियम, लैम्डा इन लिक्विड. समझ रहे हो? ये तो पता है. सो यू कैन से lambda v upon lambda m. M stands for medium, okay, and v stands for vacuum. So what will be lambda medium? It will be lambda v upon mu. Agreed? तो जो मेरा फ्रिंज विड्थ है एयर में, in air बीटा, तो बीटा क्या होता है, कैपिटल डी लैम्डा अपॉन स्मॉल डी. ओके, एंड बीटा डैश लिक्विड में मान लेते हैं. लेट इन लिक्विड the fringe width becomes beta dash. So beta dash would be, I am not going to change any capital D, neither I am going to change small d, only lambda will become lambda medium. Agreed? जब एयर में था तो लैम्डा वी कैन से वैक्यूम या लैम्डा एयर, आप इसको एयर भी लिख सकते हैं. इन एयर VA हैं, लैम्डा A रादर, सिंपली यहाँ लिख दो लैम्डा A. ओके, एंड ऑल्सो हियर लैम्डा A. So we can say this is lambda A. So can we put the value? So we shall get capital D upon small d, and lambda m क्या था, lambda m is lambda A upon mu, right? Now can you find your capital D by D, because already you have been given how much, बीटा की वैल्यू दी हुई है ना. सो बीटा की वैल्यू कितनी दी हुई है, 2.0 mm. यस, एग्रीड और नॉट एग्रीड. सो ये वाला जो है you can write it as d lambda A upon small d into 1 upon mu. So this whole thing, इसकी जगह क्या लिख दो आप, 2. Okay, so what will be your beta dash? So your beta dash would be 2 mm, or rather 2.0 mm, because you have to see what is the level of 2.0 mm upon what's the value of mu, 1.33. So it will be reduced, so it will be 1.5 mm. That's your beta dash. Tell me how much of this concept is well understood. विधि, ये कॉन्सेप्ट समझ में आया नहीं?
हाँ जी, इसका अभी पढ़ूंगी क्लास के बाद इसको, तो समझ आएगा.
क्लास के बाद तो समझ में आ जाएगा, बट क्लास के दौरान समझ में आ रहे हैं नहीं, उसके बाद तो फिर स्टैंप लगनी है. ऑब्वियसली वी विल, व्हेन यू स्टडी यू रीएम्फसाइज द होल कॉन्सेप्ट. हाँ जी आयोन जी, हाँ ना कुछ तो बोलोगे?
यस सर, समझ आ रहा है.
ओके, क्षितिजा?
यस सर, समझ आ गया.